ch13, chapter 13, sinusoids. Example 33, find the phase relationship between the following waveforms. V equals 25 sine of omega t plus 80 degrees, and I equals 4 sine of omega t minus 10 degrees. So V is the voltage and I is the current. The way you find this is whatever these phase angles is higher is the leading sine wave. Also, both of them need to be positive sine WT for omega t form. If they aren't, you need to use the sine formulas, convert both into a positive sine formula. And notice both are the same frequency. They both have just the omega, which is the same thing. So the way you do this is you take the plus 80, subtract the negative 10, so 80 minus 10 is like 80 plus 10, so it's the voltage leads I by 90 degrees, or you could say I lags V by 90 degrees, meaning the current lags the voltage by 90 degrees. Number 46, find the average value of the periodic waveform. This is an obscure waveform. The formula, you have to find the average value. G is the algebraic sum of the areas under the curve divided by the length of the curve. So the area of this piece is 1/2 pi r squared, r being 20 milliamps. So 1/2 pi times 20 squared gives you 628.32 microamps. And G is that area divided by D, and that D is this length right here, which is 20 times 2, because this is the peak, and we're going, since this is a circle, and that's 20 to the halfway point, and then another 20 to here. So you take that, divide by 40, you get 15.71 milliamps, and then you're taking the sum of the areas. So you take this G times pi, which is this length, and then take a -5, which is this value, times another pi, which is this length, and then divide it all by 2 pi, which is the total length, which gives you 5.36 milliamps. And problem 50, write the sinusoidal expressions for voltages and currents having the following RMS values of the frequency of 60 Hz with 0 phase shift. That means theta equals 0. So 4.8 volts. How do you get this? Well, omega for all three of them is 2 pi f, which is 2 pi times 60, which is 377. And then to get the maximum peak, the peak value, you take the RMS value, which is what they gave you, and multiply it times the square root of 2. So you take the 4.8 times the square root of 2, you get 6.79. That's how they got this. And then you take the 50 milliamps times the square root of 2, you get 70.7 milliamps times sine 377t, and then 2 kilovolts, 2000 times square root of 2 equals 2.83 times 10 to the 3 sine of 377t.